Example 2, dose, or do, as the French would say. Parlez-vous français? Oui, mademoiselle. That's all I got. I only spent a couple weeks, not even a whole week. I only spent like 6 days in Paris. Anyways, the following table shows the relationship between the cups of lemon juice and the number of lemons squeezed. So we're squeezing lemons and we're making lemon juice. Yay! When life gives you lemons, you squeeze them. Write an equation to represent the relationship. So equation. So immediately they're asking me to write an equation. I know that's going to be of the form y equals kx. That's what's immediately jumping into my brain. And then, there's a then. We always hate when there's a then. State what coordinate point is an x comma y, would represent the unit rate. Remember that a unit rate must have 1 in it. It's 1 comma r for the unit rate. All things that get you points here by just writing stuff down. You're proving that you know all this stuff. So in order to do any of these things, in order to write the coordinate point that represents the unit rate, in order to make the equation that represents this relationship, I need to first find the unit rate. So I'm going to first find unit rate. Bloop, bloop. So we want to know how many cups of juice per lemon, or how many lemons per cups of juice. They want to show the relationship between, cups of juice per lemon. Yeah, we want to know how much juice 1 lemon gives us. That makes sense. Notice how I had to talk that out a little bit. So cups of juice, how much juice per lemon is what we're going with. All right, so I'm going to pick one of these rates in this table here. Cups of juice per lemon. Let's go with the 30 and the 15 because that looks nicest. You can really pick any one of those numbers, but if my thing would let me, I'm going to go with the 30 and the 15 because those are nice, pretty numbers. So cups of juice on the top, so 30 cups of juice divided by 45. So I'm jumping to my calc, 30 divide 45. Oh, imagine that. In the lesson titled With Fractions, we've got another repeating decimal that we cannot round. We have to keep this as a fraction. So I'm going to make a note. Ugly decimal. So just simplify your fraction. What goes in to both 30 and 45 that I can simplify by there? Bum, 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 bum. Definitely 5. Maybe 5. Maybe you thought of something bigger. Good for you. You only have to do this once. 30 divided by 5 is 6, and 45 divided by 5 is 9, which I can immediately see that there's another thing I can simplify by, and that would be 3, trace, 3. 6 divided by 3 is 2. 9 divided by 3 is 3. So 2/3 of a cup of juice per lemon. Because again, the rate, the labels are most important here because it's not a unit rate until you have those labels on it. So 2/3 of a cup of juice for each lemon squeezed. So first part was write an equation. Now that I have my unit rate, I can absolutely write an equation. So y equals 2/3 x. There's my equation. Boom. Next, what coordinate point would represent the unit rate? Well, the unit rate is 1 comma r. The unit rate is 2/3. And there is the coordinate point that represents the unit rate. So this is the unit rate point, and this is my equation. And we've answered all parts of the question. Yay for us. Smiley face. So again, nothing really brand new, just that we need to be keeping our repeating decimals as fractions, not rounding them.